Measuring time. Electronic timer is widely used to measure time manually in laboratory. Stopwatch is a cheap electronic timer. Here is a stopwatch. It reads 0.03 second. So the reading is correct to 2 decimal place. So its resolution is 0.01 second. This stopwatch is available now in all mobile phones. Time measurement is very important in physics laboratory, but time taken by experimenter themselves is very inaccurate, because when an experimenter takes time, its reaction time is about 0.2 second involved. When the stopwatch is stopped, again 0.2 second is involved. So while taking time, total 0.4 second error is introduced with the time. So if we consider 1% percentage uncertainty, then the time should be more than 40 seconds. Then the uncertainty will be less than 1%. If time is less than 40 seconds, then percentage uncertainty is more than 1%, and that time measurement will not be accepted. The electronic timer here is very available and very easy to use. There are only few buttons. Here start and stop button, and there is reset button. This timer is started and stopped by pressing these buttons, and when needs to reset, just press this to reset. When time is less than 40 seconds, the electronic timer is not suitable for measuring time. In that case, we can use these devices: Tickity Primer, light gauge system, video camera, and oscilloscope. Tickity Primer. It is an electromechanical vibrator run by alternating current. The frequency of the vibrator is the frequency of the alternating current. A paper tape is attached to the object going to move. A metal nail is firmly joined to the vibrator head so that it can produce dots on the paper tape moving through the vibrator along with the moving object. Here is a diagram for Tickity Primer. This is the Tickity Primer or electromechanical vibrator. With the head, there is a pin attached with the vibrator. The vibrator is run by the alternate current. It vibrates with the frequency of the alternate current. At home, 50 Hz frequency is very available. Alternate current of 50 Hz is available also in physics laboratory. So the frequency of this vibration is 50 Hz. The paper tape, this paper tape attached with the moving trolley and also passing through the vibrator. When the trolley moves, dots are produced. Then the paper tape is cut into pieces. After the experiment, cut into pieces, each piece having 5 dot spaces or 6 dots. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 or 5 dot spaces. Consecutive time between two dots is 1 by 50 Hz, means 0.02 second. So each piece here represents time about 0.1 second. There are 5 dot spaces. Each dot space takes 0.02 second. 5 times 0.02 means 0.1 second. Now, by measuring length of piece of paper by measuring scale, we can easily find the speed of the moving object. Tickity Primer has serious drawbacks, such as when vibrator head produces dots on the paper tape, an extra resistance against motion is introduced. Not only that, it cannot measure time less than 2 seconds precisely. So better to use light gauge system if possible. Light gauge system consists of 3 devices: light gauge, data logger, and computer system. Infrared wave is passed through the gap of the light gauge. While an object passes through the light gauge, the timer of light gauge is started when the object reaches to the gate and blocks IR to reach to the other end. The timer is stopped when the object leaves the gate and IR reaches to the other end. So when infrared, here is light gauge system, this is light gauge, here sensor, IR sensor, IR detector or receiver. IR means infrared. Infrared sends from here, here it receives, and the information, timing information, is passed to the data logger. This is data logger connected to the computer system or software. There are 2 light gauge system is used to measure acceleration of the moving trolley. When moving object passes through it, when it blocks the IR, then timer is started. When it moves off the light gauge, then the IR again passes and the timer is stopped. This way, this system measures time of a moving object passing through it. Thus, the light gauge measures the time which is taken by an object to pass through. Speed of the passing object can also be calculated by dividing the object length by the measured time. So, the object length, if we measure the object length and we divide by time, then we will get the speed by which the object moves through the gate. This gate can be represented diagrammatically by this following simplified diagram. Here is light source, this is timer, data logger, computer system. This is simplified diagram for light gauge system. Video camera also another alternative to take time when time is less than 40 seconds. Here in this diagram we see the video camera. Here the moving object, and there is a meter rule along with the path of the moving object. This meter rule is used to determine the position of the moving object at a certain time. This video camera takes 50 images per second, or FPS frame per second, 25 frame per second, means 25 images are taken per second. So time taken between 2 successive images is 0.04 second. 1 by 25 is 0.04. So knowing the position of an object at different times or different images, time taken by an object to move from one point to another or one image to another can be measured easily. By using video editing software, time between 2 images can be obtained directly. In this picture, the motion of a trolley down a runway being recorded by video camera. A meter rule is placed along the path of the moving trolley to record its position in the video images. Here there are 2 images, 2 pictures of the video editing software, and we see the moving object trolley, 2 moving object here. This image is taken at a time 5.505 seconds, shown here. This image is taken at time 5.872 seconds, shown here. So time taken by this trolley to move from this image to this image is 5.872 minus 5.505, means 0.367 seconds. The time can be taken by this video camera. If we want to measure very precisely time, then we can use oscilloscope. Oscilloscope is more better option, but this is very limited use because oscilloscope only measures when voltages are taken. So we have to use some sort of sensors which convert physical data into voltage, then oscilloscope can be used. Oscilloscope is mainly a voltage measuring device. It is used to measure low or high frequency alternating or digital voltages at a particular time. There is a high precision oscillator that is used to display a voltage signal according to the time-based setting set by the time-based controller. The middle horizontal line is time axis. This is time-based controller. This is the display. This is horizontal axis, here is vertical axis. Here we see the voltage signal. This is voltage controller. In this time-based controller, we see there are 6 options. 1, 2, 3, 4, 5, 6. 10 millisecond, 1 millisecond, 0.1 millisecond, 10 microsecond, 1 microsecond, 0.1 microsecond. Now the setting is at 0.1 millisecond. It means that each division here to here means 0.1 millisecond. There are 10 horizontal divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 horizontal divisions. Each division is equal to 0.1 millisecond. There are 8 vertical divisions. 1, 2, 3, 4, 5, 6, 7, 8. 8 vertical divisions represents voltage. Now voltage setting is 5 volt. 5 volt voltage setting. It means that each division represents 5 volt. In this oscilloscope, the display is divided into 10 horizontal divisions and 8 vertical divisions. Already we discussed this. Here the setting is 10 millisecond. So each division is again divided into 5 small divisions. So 5 smaller divisions. So at 10 millisecond per division setting, resolution of the timer is smallest unit. So 10 millisecond by 5, there are 5 smaller units in each division. Each division is 10 millisecond. 10 millisecond divided by 5 means 2 millisecond. So at 0.1 microsecond per division setting, resolution is 0.02 microsecond. And at 10 millisecond per division, the resolution is 2 millisecond. The physical sensors like light sensor, heat sensor, magnetic sensor, etc. convert physical data into voltage signals. Using oscilloscope, measuring voltage against time, we can measure time very precisely up to microsecond in a school laboratory. Here is a signal, the 2 points P and Q. Now we want to measure time and also frequency of this signal. The voltage setting is 0.1 microsecond. There are 5 divisions and 3 small divisions between points P and Q. Points P and Q, division 1, 2, 3, 4, 5. 5 divisions. And how many smaller divisions here? 1, 2, and here 1. So 3 small divisions. So time taken is 5.6 division. So 3 small divisions means 0.6 division. So by 5.6 division, and each division 0.1 microsecond. So time is 0.56 microsecond. If we want to measure frequency, then we need to know the time taken between two consecutive peaks. This is one cycle, this is another cycle, another cycle. Between these two consecutive peaks, what is how many divisions are there? Small divisions here, 1 2 3 4 4.5, and here 1 2 3 1 2 4.5 and 3.5. So total 8 small divisions between this and this point. 5 is small division equal to 1 division, so there is 1.6 division. Each division 0.1 microsecond, so time between these 2 points is 0.16 microsecond. Period equal to 1 by period is 0.1 microsecond, time taken to complete one oscillation. Frequency equal to 1 by period, so 1 divided by 0.16, 10 micro means 10 to the power minus 6, so this is 6.25 megahertz. So frequency of this voltage signal is 6.25 megahertz. Using oscilloscope, we can measure frequency as well as time, small time, very precisely.